Hi, my name is Jesslyn, and this video is about arithmetic sequences. So, arithmetic sequence is a sequence that goes up by a constant rate, either adding to the pattern or subtracting to the pattern by a constant rate, like adding 5 each time or subtracting 20 each time. So that's an arithmetic sequence. You're adding or subtracting what we call a common difference. Okay, so in this case, 3, 8, 13, 18. I can see that I am going up by 5. I'm adding 5 each time. So the common difference, which is represented by the letter D in this case, is 5. So the common difference represented by the letter D in this case is 5. So that is how you do that. And so let's look at the formula. So the formula for arithmetic sequence is a to the n is equal to a1 plus the common difference times n minus 1. We already know what d is. D is the common difference. But a to the n is the nth term. That's really what we're solving for. So if I say the 40th term is 200, then that would represent a to the n. That 200 would represent a to the n, the 40th term. And then a1 is the first term. D is the common difference. And n is the term number. The term number. Like if I'm saying I want to know the 35th term in the sequence, then 35 would be n, okay? So make sure if you're taking notes, make sure you write all that down because I'm about to erase it. So for an example, pause the video. So for an example, I'll leave the formula up here. You can read it. Usually it's this type of A, sorry. Oh, that looks not like minus 1. Okay, so for an example, if we had 79, 75, 71, 67, and so on. The easiest way when given a pattern is to find the common difference first. So the common difference here, if you notice, it's going down by 4 each time. So the common difference is negative 4 because it's going down, so it's negative. So the common difference is negative 4. And then we also know A1. I don't know why I keep drawing it. We also know A1. A1 is 79. So we need to know everything but one. So we know A1, we know D, and so we can write the equation to this by plugging it in. So a to the n is equal to A1, which is 79, plus the common difference, which is negative 4, times n minus 1. Okay, so here's the equation. So, but we can actually simplify this equation even more. So a to the n is equal to 79 plus we can do distributive property. So negative 4 times n is negative 4n, and then negative 4 times negative 1 is a positive 4 because negative and a negative, positive 4, and then I can combine 79 plus 4. So 79 plus 4 is 83. So 8 into the n is 83 plus a negative 4n. And technically, I can even not write the plus and negative 4. I can just write minus 4n. So here is my equation for that or this. You might see both of them. They're both the right. This is just the simplified version. Okay, so that's the equation for that pattern. And now I can use this equation, and if I say, hey, I want to know A of 45, which means that I want to know the 45th term, then I plug in 45 for n, plug in 45 for n. 83 minus 4 times 45. If I do that, I am going to get, if I solve that, I'm going to get A45 is equal to negative 97. So the 45th term is negative 97. All I did was take 45, because I'm looking for the 45th term, and I plugged it into my formula. If you plugged it into this formula, 45, you would get the same thing, okay? You'd get the same thing. It'd be totally fine. You can use either equation depending on what your teacher wants. If she wants the simplified version, then right here, but then that version. Okay. Oh, okay. Now we're using the same formula, and it's asking what term, so what number of term is 169? So what number is negative 169? I think it's negative 169. So in this case, we are given the a to the n because we're saying what term number is negative 169. So we're looking for the n because that's the term number, right? N stands for the term number, which means that negative 169 would be plugged in to here. So negative 169 is equal to 83 minus 4n. And we're going to solve that equation. So minus 83 on both sides. We get negative 252 is equal to negative 4n. Can you still see it? Yeah. Negative 252 is equal to 4n. Divide by negative 4. Again, lots of solving equations. And you got to make sure you have solving equations down to do algebra because it's everywhere in algebra. So n is equal to 63. Okay? N is equal to 63. So that means the 63rd term will give you is negative 169 in the pattern. Let's do another example. Oh, I shouldn't have erased that equation. I'll rewrite it. The more I rewrite it, the more I put it to memory, right? So an example, if I know A10 is 3.25 and I know A12 is 4.25, I want to find the equation for this. So what this is telling me is that the 10th term is 3.25 in the pattern, and the 12th term is 4.25 in the pattern. It's telling me it's an arithmetic sequence, so what I want to do is find the common difference. I can find the common difference anywhere by finding the difference of these two over the difference of their positions. So the difference of these two, 4.25 minus 3.25, and then if I chose this one first, subtract that one, I need to choose this one first, minus 12 minus 10. So the difference of what they are over the difference of their positions, okay? Kind of like the slope formula, but you have to know the difference of their positions goes on bottom. So this is 1 over 2. So the common difference is 1/2. If you want to change that to a decimal, 0.5, you can. So the common difference is 0.15. So now I know the common difference. So now I can take either of these, plug it into here, and figure out the first term. Because to write an equation, you need to know the first term and you need to know the common difference. And that's it. You need to know the first term and the common difference. So we need to figure out the first term. So I know the common difference is 0.5, so I'm going to write that up here to remind myself. And then I'm going to write A10 is equal to 3.25, and I'm going to plug this into my equation. So 10 represents that the 10th term is this. So if the 10th term is this means that it's a to the n, 3.25, equals, we're looking for a to the first, we don't know that, plus d, which is the common difference, 0.5, n minus 1. N stands for the term number. If I know a to the 10 is 3.25, then to plug into this, I can write 10, because that's what a to the n equals right now. Okay? Now I'm solving for a to the first. If I were to plug in the other point, a12 equals 4.25, and do 4.25 and then 12 here, I'd get the same answer. So now I'm going to solve this. 10 minus 1 is 9, and then half of 9 is, 10 minus 1 is 9, and then half of 9 is 4.5. Subtract 4.5 from both sides. And then we get A1 is equal to, A1 is equal to negative 1.25. So now I know the common difference, I know A1, and I can write that equation. Okay, so AN is equal to negative 1.25 plus 0.5 times n minus 1. And there you have the equation. Again, you can simplify this by distributing it out and simplifying it even further, but I'm going to leave it right there for right now. Okay, the next thing you want to learn is how to figure out the sum of a series. So the sum of an arithmetic series. It's found by, and I'll write it up here, it's found by n, and then a1 plus a to the n, and then all divided by 2. Okay, all divided by 2. N is the number of terms that you're doing. Let's say the series consisted of 100 terms, so n would be 100. So n's the number of terms. A1 is still the same thing, it's the first term. And a to the n is still the same thing, it's the nth term. Okay? And this is written usually in sigma notation. So to find the sum of a series, it's written with that funky E, that funky E called sigma notation, and it would have P equals 1 and then 50, and then it has an equation out here. What sigma notation says is that our numbers go from, the different numbers go from 1 to 50. So it starts at the first term and it goes to 50. So we plug in 1 for here, and then we would figure out what the first term is. So sigma notation, we want to find the sum of it. We start with 1. Plug in 1 for P, and then plug in 50 for P, and we'll find the first and the last number. But for the sum, we need to know the number of terms. Well, we know the number of terms is 50, because that's what this represents right here, 50. And we know what A1, well, we don't know what A1 is, but we can solve for A1 by plugging in 1 for P. So N represents 50. A1, we'll solve for that. Let's solve for that. So 73 minus 2 times 1, because it tells us that 1 is the first, if we plug in 1, that is the first term. 73 minus 2 is equal to 71. So A1 is equal to 71. And then we have A to the N. Okay, so A to the N is the last term. And so since we know the last term is number 50, we plug in 50 there. So 73 minus 2 times 50, 73 minus 100. And 73 minus 100 is negative 27. So A to the N is equal to negative 27. So we have all of these, and now we can put it into the equation to solve for the sum. So I'm going to erase it, and we're going to do the sum. So I have all of these. So n is 50. So the sum, instead of writing n, I'm going to write 50 times a1 is 71. 71 plus an is negative 27. And then all divided by 2. Okay, so now I just solved this. So 71 plus negative 27 is 44. 40 times 44 divided by 2. And the sum is going to be 11. So the sum of this series, where a1 is 71 and the last term is negative 27, and it follows the rule 73 minus 2p. Well, if we added up all those numbers in that term, we would get 11. And so that's how you find the sum of the series. Thank you for watching.